Hello and most welcome to 1240 of the Heidegger series, and we will continue with Roberto Unger. I'll say it's one of the most interesting things I've been reading lately. He is a Brazilian philosopher, how odd is not that, to start off with. And he's been cooperating with a renowned physicist, Lee Smolin, and written a lot of articles, books, and so forth. There are two main lines or theses in the understanding. And the first one is the singular universe, which means that Roberto Unger points out that there is a tendency going back long before Everett, I would say, that to see the universe as being copyable or being in several issues, that being a possibility. And this is caused by this, I would say. You see arrows here outside the borders of the universe to check it out, to have an observation of the universe from the outside. This is where the complications start, I would say. And one example of this that he often gives is that we are taking a small experiment in a closed-off limit zone like this one I'm standing in now, the room here with a view, and we scale it up to cover the whole of the universe. Doing so, we forget that the room or the laboratory can actually literally be viewed from the outside, but the universe cannot. So, are we allowed to do this? Roberto Unger says, well, we're definitely not allowed to do it without saying so, without thinking about it. And I would say he adds also it's impossible. But this has been happening slowly, the scaling up, and we have not really been aware of it. I don't think so. It's very hard to be aware of such things. And Roberto Unger is so clearly pointing it out, of course, the cooperation of Lee Smolin. The second thing is the existence of time. In a deterministic cause and effect system where everything hooks up, there is little chance of any freely moving time. And of course, together with the laws, you can see how laws plus cause and effect these together, and you don't have much of free move of time. If you have laws and cause and effect, you will have no free flowing time. And even such a thing that the laws have always been the same makes free time even harder to get at. So time as existing means time is freely flowing and you cannot say where it's going to go with use of laws before. Then you have no free time. Then I continue where I took off or left off in lecture 1239 of yesterday, the 6th of November. And we continue now. The mathematics that we develop on the basis of this indirect relation to nature, driven by an agenda internal to mathematics itself, may or may not apply to the elucidation of natural phenomena. It may or may not be useful in the work of natural science. There is no assurance that it would be serviceable, although it often is. The ultimate source of its powers is that it combines connections to nature with distance from nature. This power perennially tempts us to succumb to two connected illusions. The first illusion is that we have in mathematics a shortcut to undubitable and eternal truth. Somehow superior to the rest of our fallible knowledge. The second illusion is that as the relations among mathematical propositions are timeless, the world itself must somehow participate in the timelessness of mathematics. Here we offer an account of mathematics that has no truck with either of these illusions. It is a realistic and deflationary view. It claims that we cannot make adequate sense of the effectiveness of mathematics in natural science by treating mathematics either as the exploration of a separate world of timeless mathematical object, or as the free invention of ideas about number and space that turn out to mysteriously be applicable to nature. We enjoy our mathematical powers for natural reasons. We did develop them at first inspired by nature, eviscerated of time and particularity, and then at a distance from the original sources of our inspiration. Mathematics, however, is smaller, not greater than nature. It achieves its force through a simplification that we can easily persuade ourselves to mistake for a revelation and a liberation. The view of mathematics as the imagination of a counterfeit version of the world, robbed of time and phenomenal particularity, acquires its full force and meaning only when combined with the other two ideas central to our argument, that there is only one real world and that everything in this world changes sooner or later. One world, real time, mathematics is about the one world in real time. Not about something else. Not about something else, very important. Instead of trying to find what else mathematics could be about, other than the world, in parenthesis, there is nothing else. We should be concerned to understand in just what sense it can be about a world, to the manifest qualities which it is so strikingly and willfully blind. And that leads us to the first cosmological fallacy. There is one real universe. Time is real, and nothing lies beyond its reach. Mathematics has the one real time-soaked world as its subject matter and inspiration. It is useful to the understanding of this world precisely because it explores the most general features of relations among pieces of the world abstracted from both time and phenomenal particularity. These three propositions form the axis of the argument of this book. To recognize and to develop the truth that they express, we must reject two fallacies. Each of these fallacies enjoys widespread influence within and outside physics and cosmology. They are closely together. Taken together, they summarize much of what is misguided in our received understanding of the discoveries of science. Call them the two cosmological fallacies. Both of them mistake a part for the whole. They make different but connected mistakes. The first fallacy applies to the whole of the universe methods. And ideas that can be successful only when applied to part of it. It is a fallacy of false universality. It treats the whole universe as if the whole were one more part. The second fallacy embraces a view of nature and of its laws that is inspired by the forms that nature takes during part of the history of the universe. It is a fallacy of universal anachronism. It applies to the whole history of the universe. Ideas that are pertinent only to the part of that history. Its view of the workings of the natural world is too parochial to do justice to the metamorphosis of nature. The first cosmological fallacy a fallacy of false universality applies to the whole of the universe and therefore to the central problems of cosmology, what we here call the Newtonian paradigm. The Newtonian paradigm is the chief method of explanation that physics and cosmology have deployed since the time of Galileo and Newton. Relativity and quantum mechanics have not disturbed its ascendancy, however much they may have modified its application. Under the Newtonian thinking at the same time. Under the Newtonian paradigm, we construct a configuration space within which the movement and changes of a certain range of phenomena can be explained by unchanging laws. The range the range of experience defined by the configuration space and explained by the laws can in principle be reproduced, either by being found in another part of the universe or being deliberately copied by the scientists. The recurrence of the same movements, and the same changes under the same conditions or the same provocations confirms the validity of the laws. The configuration space within which changeless laws apply to changing phenomena is marked out by initial conditions. These conditions are the factual stipulations defining the background to the phenomena explained by the laws. The stipulations mark out the configuration space. The space within which laws applies to the explained phenomena. By definition, they are not themselves explained by the laws that explain movement and changes within the configuration space. They are assumed rather than explained. It's a little bit to take in here, I would say. however, that they perform in a particular part of science the role of unexplained stipulations rather than of explained phenomena, does not mean that they cannot reappear in another chapter of scientific inquiry as subjects for explanation. In the practice of the Newtonian paradigm, what is stipulation for some purpose becomes the subject matter to be explained for another. That the rules of what is to be explained and what does the explaining can in this way be reversed ensures that we can hope to explain all of universe part by part. The observer stands, both in principle and in fact, outside the configuration space. Conceptually, his relation to it resembles the relation of God to the world in Semitic monotheism. Judaism, Christianity, and Islam. Not as creator, but as observer. He looks upon it, to use an astronomical metaphor, from the vantage point of the stars. The laws go together with this ideal observer. They govern what happens inside the configuration space. They have, however, no history of their own within that space, or anywhere else. The laws determine changes or movements within that configuration space. Thus, they can be used to explain events in time. To explain changes of the phenomena. It is first necessary to represent them. The most familiar way in which to do so is to plot them as movement along an axis. Time is converted into space. The laws are timeless. They have no history. They underlie and justify our causal explanations. They are, however, themselves without explanation. To ask why they are, what they are, is to pose a question that lies in principle beyond the limits of a natural science conforming to the Newtonian paradigm. Those whose ideas about the practice of science have been formed in this mold may hope to find in mathematics the beginnings of insight into why the laws are what they are. This conjecture remains, however, no more than a metaphysical speculation with limited practical significance for the conduct of science under the guidance of the Newtonian paradigm. The first cosmological fallacy consists in the application of this way of doing science to the universe as a whole. Which is to say, to the problems that are distinctive to cosmology. When the topic is the whole of the universe and its history, rather than a part of the universe, the distinction between law-governed phenomena within the configuration space and the stipulated factual conditions defining that space ceases to make sense. There is no place outside the configuration space for anything else to be. That space has become the entire universe. It is no longer thinkable even in principle to prepare or even to discover copies for what we are to explain. Now the entire universe, so that we can test the constant validity of the laws. Deaf to Newton's warning not to feign hypotheses, we may appeal to the idea of multiple parallel universes in an effort to rescue the cosmological use of the Newtonian paradigm. If, however, these other universes are, as they must be, causally unconnected with our own, and no light-borne information can travel from them to us, this conjecture will amount to no more than a vain metaphysical fantasy, disguised as science. The process by which what is the factitious stipulation of an initial condition in one local explanation becomes an explained phenomenon in another is now interrupted. In an account regarding the whole universe and its history, no occasion arises for such a reversal of roles. Thus, no hope can be well-founded that by accumulating local explanations, we slowly approach an explanation of the whole. The observer can no longer stand outside the configuration space and claim to adopt the godlike view from the stars. All the stars and everything around them are dragged down into the field of explanation. If the laws of nature are somehow exempt from the violent changes that nature undergoes, they must exist on some other plane of reality, in the company of mathematics, as it is understood by mathematical Platonists. Thus, every feature of the Newtonian paradigm fails when its subject matter ceases to be a region of the universe and becomes the entire universe. The denial of this failure is the substance of the first cosmological fallacy. It results in a series of equivocations that corrupt the practice of scientific inquiry and prevent cosmology from remaining faithful to its vocation to be a master science rather than a sideshow. A major stratagem by which to dismiss or diminish the implications of seeing the first cosmological fallacy for what it is consists in treating the problems of cosmology as peripheral to the agenda of physics in particular and of natural science in general. The parts of the universe, however, are parts of the universe. Our view of the universe and its history has implications for our understanding of all its parts. If, for example, there is a succession rather than a plurality of universes, And if the causal connection between successive universes, although stress, is never broken, many features of our world may have their origin and explanation in the traits of the very early universe or universes that preceded them. An influential variation on the strategy of marginalizing cosmology, the better to suppress the embarrassment it creates for the established scientific ideas and practices is to represent the earliest movements of the universe as characterized by the infinite degrees of temperature and energy. That is precisely what marks a singularity in the strict and conventional sense. Once we cross the threshold of the infinite in the representation of nature, we can no longer make use of any of the explanatory practices. Including the Newtonian paradigm that we are accustomed to apply to the world of nature that we know. Thus, under the view that the present universe began in a singularity, the parameters of which are infinite, rather than in the violent event of extreme but finite parameters. We can attribute to the enigmas of the infinite what are in fact confusions and contradictions resulting from the illegitimate universalization of local explanations. It is as if the jump from the finite to the infinite provided a generic license for ideas that, in the absence of such license, would readily be dismissed as untenable. And now we're getting to the second cosmological fallacy. Be prepared, now it comes. It's getting more, second fallacy is a tough nut to crack. I'd say the first one is tougher. So now it will be easier. But they are combinatory, you can combine them. They get combined directly as to make a lock of reality, as I call it often. So do pay attention, and it needs to be read slowly at a very calm place to be understood. Because I claimed before that our very understanding is Newtonian. That is stressed, unarticulated, and not very distinct. Smokey. But of course in a very, very slight way. Very, very diminuted way. But it's a thinking fault underlying everything. The second cosmological fallacy, a fallacy of universal anachronism, sees the entire history of the universe from the standpoint of ideas that may be pertinent to only part of that history. It incorporates into our practices of scientific explanation a view of the workings of nature that accounts for those workings only in a certain states of nature, but not in others. The substance of the second cosmological fallacy is to treat the form that nature takes in the differentiated cool-down universe as its sole and permanent form. This model of the workings of nature can be read backwards as well as forward to earlier and later movements of the history of the present universe, as its one and only mode, hence the mark of the universal anachronism. It is a cosmological fallacy because it can arise only within cosmology. And as a result of its most significant discovery, the discovery that the universe has a history. The second cosmological fallacy is thus no mere methodological missteps. It amounts to a misreading of the facts of the matter. It concerns the most important contribution that cosmology has made to our understanding of the world. The import of the second cosmological fallacy is that our received image of both nature and natural science is modeled on a historically parochial view of how nature works. Cosmology has long since denied us any entitlement to such parochialism. We nevertheless remain reluctant to give it up. There is no invariant or quintessential scientific method. Our views of the practice of science develop together with the content of our scientific ideas. The discovery that the universe has history and so therefore must everything within it be historical, has implications for the practice of science. We have so far failed to acknowledge them. It is not just any history. It is a particular history. We already know enough about it to begin to form the idea that nature can exist in different states or wear different masks. Our prevailing conception and practice of scientific explanation take only one of these states for granted and identify that state with the necessary and universal workings of nature. In so doing, however, they fail to take adequate account of what cosmology has already discovered to be the facts of the matter. At least if we interpret its findings undistracted by metaphysical prejudice. yet on any of the accounts of the origins of the present universe that now command authority. We have reason to think that the workings and characteristics of nature were once very different from what they have since become. These views can be broadly grouped into two main families of ideas. One family of ideas predominant to this day traces the origins of the observed universe to a singularity in the now conventional sense. An original state in which the energy density of nature reached infinite value. Another family of ideas which the argument of this book accept follows the history of the present universe to an original state in which the energy density of nature was extreme, but nevertheless finite. In this second family of ideas, the conjecture of an original state of extreme energy density is readily married to the further conjecture of a succession of universes. What is striking is that is that on either of these two sets of conceptions, we have reason to suppose that the familiar divisions within the mature and evolving universe, the structural distinctions and rudimentary components of nature described at one level by the standard model of contemporary particle physics, and at another level by the periodic table, may once not have existed. Of course, the chemical description of nature, as summarized in Mendelev's periodic table, is not fundamental. It is nevertheless connected through many intermediate links, such as the Dirac equation and the Pauli exclusion principle, to the fundamental description offered by particle physics. The idea of permanent differentiated structure of natural phenomena is central to the dominant tradition of modern science. Darwinism, and more broadly, the earth and life sciences, have barely made a dent in the ascendancy of this vision. So here we are taking a certain part of time out of the context and saying that the universe should be seen as this stable, non-moving way. And we make that the start, the foundation, which to explain everything else. This is once more scaling up something limited into the whole time of the universe, from start to end, from Big Bang to the Big Crunch. Roberto Unger shows that this is an unfounded and illicit move. I would say too hastily done and forgotten about. this is interesting. Darwinism and more broadly, the earth and life sciences have barely made a dent in the ascendancy of this vision. The idea of an ahistorical differentiated structure does not live exclusively in the forms of science that explore fundamental levels of reality. Particle physics first among them, but also in the sciences. Chemistry, for example, that address nature at less fundamental levels. Unless we are to subscribe to a radical reductionism incompatible with the way in which the physical sciences have developed, there is no reason to disregard the less fundamental descriptions and to focus solely on the more fundamental ones. The notion of a timeless structure must be contested and overthrown at all levels, the less fundamental ones as well as the more fundamental ones. In the meantime, chemistry, like particle physics, continues to be a structural science rather than a historical one. It is not simply on this line of reasoning that other structural distinctions and rudimentary components mark nature in the very early universe. It is that the presentation of nature as differentiated structure and it's working as an interaction of clearly distinct forces or fields may then have failed to obtain. Such distinctions and interactions could not have existed under the conditions of the very early universe. If they existed at all in the circumstance of the original extremes, they would have had to have been radically different and to have worked in a radically different way from how they later came to be and to work. A premise of much established thinking in cosmology and physics is, nevertheless, that nature works always and everywhere as a structure of distinct parts, particles, fields, forces, interacting with one another in conformity to unchanging permanent laws. Very important. The criticism of the second cosmological fallacy has as its aim to explore this contradiction within our present beliefs about the history of the universe and to consider its implications for the practice of science as well as for the content of some of our most comprehensive scientific theories. The whole argument represents a natural philosophical reflection on what it would mean to take altogether seriously the idea that has been central to cosmology ever since Lemaitre and his conjecture about the origins of the universe gained widespread acceptance. In this reflection, I resort to a heuristic device. I imagine two states of nature and say nothing about the transition from one to the other, this contrast in terms of which I sketch it far exceeds the authority of the evidence. Moreover, it's couched in terms that could not figure among the formulations of a developed scientific theory. Nevertheless, it serves a legitimate analytic purpose. The aim of exposing the logic of the idea that nothing in nature lasts forever. In particular, it makes this logic explicit in the context of the second family of beliefs, which I have just referred. Those that propose extreme but not infinite values of the earliest states of affairs in the history of the universe. The strategy of the heuristic argument is to contrast only two states of nature and to suggest nothing about the transition from one to the other. The stark simplifications and the metaphorical language to which I here appeal in no way undermine the usefulness of the argumentative device. The core point is that the research agenda and the way of thinking inspired by Lemaitre's conjecture failed to be fully achieved if we content ourselves with the idea that the early universe had a different structure. The implication of the conception of the original state is that it had no structure at all. In the familiar sense of the concept of structure to which the scientific study of mature universe has accustomed us. Because it had no such structure, it must also be supposed to have worked in a very different way. Moreover, the significance of the device is not limited to finitistic views of the original state. Accounts of the original state of the universe that restrict all parameters to finite values. It is pertinent as well, albeit in a different way, to views that invoke a finitude-defying singularity. For, according to such views, there must also have been a moment when the distinctions and interactions of the mature universe did not yet exist. There must have been a transition and transformation leading from the universe then to the universe later. Indeed, the transition and the transformation must have been all the more far-reaching if they accommodated, as they must have for such a conceptions to make sense, a passage from the infinite to the finite. And therein lies the riddle. There's no free lunch, but here they're giving the lunch up and still not eating it. There is a sacrificial gesture here, deeply embedded in the thinking. And Roberto Unger so clearly, and I used the expression incision before, because if you cut too much, it will cover the understanding or make it impossible. He's very exact. He shows therein lies the problem. Once this problem is established, everything that follows is logical, reasonable, sane, rational. Could be, I add myself in parenthesis, uncriticizable. But what happened in the Big Bang, so to speak, to make a little joke here, our theory building is what we must address in the view of Roberto Unger. And Unger does this with absolute exactness, sharpness you seldom see. It's just incredible. It's pure joy to read it, but it is tough to understand. So do have patience with it. And do remember, I would say this is an argument you never heard before. It is new to my ears. And also remember, I read yesterday, Julian Barber is of a certain different opinion. And I think that is completely self-evident if you think about it. Very interesting. This is big hopes for the future of understanding. I say thank you very much and have a very pleasant afternoon. Thank you for your patience. I'm sorry I made such a few comments here. There will be more once I understand more. It's a process. Good afternoon and bye-bye for now. It's rainy today, but the last insight still makes one happy. So a little rain doesn't matter.